Hey, everyone, Mr. Shatter back to take a look at what we've noticed after graphing all these parabolas. Well, now that we have all these data tables, the question is there a relationship in the data table somewhere that's going to lead us to believe that it must be a quadratic relationship? Well, the answer is going to be the difference of the y values. Let's take a look at the difference of the y values. So if we take a look at 5 to 0, so if we have to go from 5 to 0, you need to subtract 5, right? And then 0 to negative 3, 0 to negative 3 is going to be subtracting 3. Negative 3 to negative 4 would just be subtracting 1. Now we're going to change from negative 4 to negative 3, which is, we're going up now. We're getting less negative. We're actually adding 1. Be very careful with these addition and subtraction signs. They are very important, okay? And then we're going to do negative 3 to 0. We're now going up still, so it's addition of 3. And 0 to 5 is addition of 5. Now, what you're going to notice here is there is no pattern, right? Negative 5, negative 3, these numbers are not the same. This is what's called the first differences. The first differences. And recall, if the first differences of a function are equal, the relationship was linear. There was a linear relationship. But interestingly enough, we can see a pattern if we go one more time. Let's find the differences of the differences, aka the second differences. Here we go. From negative 5 to negative 3, we're going up now, right? This is getting less negative. This is addition of 2. And negative 3 to negative 1 is also addition of 2. Be careful here. This one's tricky. We're going from negative 1 to positive 1. So negative 1 to 0 is 1. 1 to positive, or excuse me, negative 1 to 0 is 1, and 0 to positive 1 is another 1. And the difference here is 2, positive 2. 1 to 3 is obviously plus 2, and 3 to 5 is also obviously plus 2. Well, what do we got here? We have the second differences. So the second time we did this, they're equal. They're all equal. This is a clear indication that the relationship must be quadratic. It's no coincidence that in a quadratic function, this exponent is a 2, and it corresponds directly to the second time we did the differences. One last thought. Look at the x values. Is there a relationship here as we move down? Yes. Negative 3 to negative 2, negative 2 to negative 1, negative 1 to 0. It's all addition of 1. Make sure if you try to play the second difference game that your x values also have common differences. For example, negative 3 to 5 to 20 to 3,487, you could not play the second differences game. Your x values must also have equal differences. So this is a way to check if a data table is quadratic.